Okay, and we are back with another Leetcode. So we're going to do binary tree pre-order traversal. Given the root of a binary tree, return the pre-order traversal of its nodes' values. Given the root of a binary tree, return the pre-order traversal of its nodes' values. Example 1, 1, 2, 3. Okay. 1, null, 2, 3. The output is 1, 2, 3. This is pre-order traversal. Okay. 1, null, 2, 3. Okay, let's see the constraints. Number of nodes can range from 0 to 100. Okay. And the value can range. Okay, so I want to get this root. The output is none. If it's 1, the output is 1. Okay, so if root equals none, return none. Return the pre-order traversal. So I want to also create some sort of an array next. So if the root is none, return none. And if root.left is none and root.right equals none, return none. So that's if it's a root node, like here, just return the root. Return the root. Then what I'm trying to do is return the array. Oh no, you return an empty array. Return the root as an array. Root.val. So much intricacy to this. Okay, so now the next thing we gotta do is create a array. Create an empty array. I'm going to create my helper function. Preorder trav root. So let's call it def pre-trav helper. So my helper function, it's going to take in self. So I'm defining it within the class. It's going to take in a node. And it's going to take in an array to keep passing through so that we can gain the so we can understand what the values of the traversed array is. So the pre-trav helper. So now I gotta figure out a base case. So I'm gonna say if node equals none, return. If node equals none, return. And then otherwise, the first thing I want to do is add values to my array. So I have to fill up ARR. So R, I have to fill that up with ARR. Then I would call self dot pre-trav helper. I would put in the root node. I would put in the ARR. Then I would return the array at the end. So after this function runs, I can get this value that's referenced here. So I take this value, I pass it into this traversal function, pass in my root node. Then this takes this array in the node that whatever it's passed traverses in a pre-order fashion. So in an in-order fashion, what happens is it goes left, add the node, right. So in a pre-order trav, I want to add the node left, right. So what I'm going to do first is array dot append node dot val, then if node dot left if there's a node dot left, I will go pre self.pretrav helper node.left array. And then what I want to do is, this is just for traversals. I'm not trying to return values, I'm just traversing. So if node.right self dot pre-trav helper pre-trav helper node dot right r. So basically, if I walk you through this, I have a root node, I check these two conditions. If it's an empty node, so if there's no nodes, the root is none, so I return empty array. If it's just the root and there's no children, I just return the root value as an array with one entry, the root value. Then I make a empty list. So what that entails is I have this empty list and I need to get the order in a pre-order traversal. So as we mentioned before, an in-order traversal goes left, add, right. Right? Now we want to add, then go left, right. So we get whatever node comes first. It's pre-ordered. So you get 1, 2, 3 in succession. So let's give this a run, see what's going on. But there you have it. Let's submit this test case. And as you can see, it beats 43.72% of the people that tried solving this problem. So what I want you guys to understand is you just have to trace your logic when you do these kinds of recursion problems. If you know how to do an in-order traversal, you have to think, okay, I'm doing the exact same thing. I'm still traversing a binary tree. What's different? What's different here than a pre-order traversal? The only difference is all the logic is actually the exact same. I just changed the order of execution within that logic. So if I wanted to make this a pre-order, I would take this, I would cut it, and this is your pre-order logic. Boom, now I had, no, if I want to make this an in-order, so if I go back to my old in-order video, this is the logic for the in-order. Right, if I want to make it a post order, all I have to do is cut this. And paste that here. So it explores the nodes first, then it gets it post exploration. Right? Right now I'm doing pre-order, so it's pre-exploration. In order is while I'm doing the exploration. Right? So this is very important to keep track of when you're doing these kinds of questions. Especially with recursion. Recursion is all about mapping your general logic and letting it flow and do its thing. So if I say go left, it's going to go left and left and left and left until it hits a base case and it goes back, 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 back. Do you see what I'm saying? So we're doing the same thing here with this question. So yeah, if you like this video, please give it a thumbs up. Please leave your comments and concerns in the comment section below. And yeah, happy coding. Knologist out.